In this video, I would like to show you some examples of how to plot functions. So here I have already written some simple code. In the first example, we can see that I have a function sine x times cosine x, and I want to plot this over the interval from -10 to 10. You can notice that I'm using the dot multiplication. This is to vectorize my operation of this multiplication. If we didn't use this, then actually it will still plot, but it will give you a warning and it will tell you that your function behaves unexpectedly, and it is better basically to properly vectorize your function. So usually you should not forget to vectorize your functions, and then you will not get any warnings. And you can see that if I run this time, I have the sine x times cosine x function over this -10 to 10, and no warnings are given this time. So this is one example. Let's consider our second example here. In the second example, we want to plot the function, so we are again using the fplot built-in function in Matlab. And you can notice that it doesn't matter which variable I use, x, y, or z, as long as my function definition here in this part is consistent. So my function is y squared minus 1. Again, I vectorize my operation of this taking the square. It's a vectorized operation now, so that Matlab can execute this properly, and I can plot y squared minus 1 over the interval from -1 to 1. And if you click, you can see the plot of y squared minus 1, which is a polynomial. So what if we want to make some surface, and if we have a function with respect to two variables? In that case, we can use the built-in function fsurt, and you can notice that this time we have a function with respect to two variables, x and y, and suppose it is x squared plus y squared. Just like the previous examples, we should vectorize each of these operations, like taking the power or multiplication, etc. They should be vectorized, and this time my x domain is from -2 to 2 for with respect to the first variable x, and the domain I would like to consider for the second variable y is from -2 and 2. So if you run this, you will see the surface that's plotted by Matlab. So it's very easy by using the fplot and fsurface functions. You can come up with one more example for the surface. Let's say we use x and y, and suppose I this time calculate sine x plus cosine y, and let's say we use with respect to the same domain. So I can comment this one and I can click run, and you can see that it just shows another interesting surface which is created by considering the sine x plus cosine of y. Okay, thank you.